All right, I am not collecting your homework. I am collecting the test though. Here's your homework. Copy down. What?
Lesson 9.4 worksheet. Why do we have homework?
No.
It's a test.
That was a quiz.
Well, still.
All right.
Can I pass out?
Do it quickly. All right, we're doing some fun, sort of, kind of. Okay, it's easier than what we have been doing. No calculators involved. I'm not sure why they put this right in the middle of this section, but it does kind of break up between area and or 2-dimension and 3-dimension. So this is, well, it is still shapes, but it has nothing to do with calculating area or anything like that. Okay. This is symmetry and reflections. Like I said, if I were writing the book, I wouldn't have put it here. I would have put it in the previous geometry section. But I didn't write the book. Here we go. Symmetry and reflections. For those of you that can remember a couple weeks back when we took the NWEA test, there were a whole lot of questions about this on the test. And some of you were like, what do they mean? Line of symmetry. I don't know what that means. Well, unfortunately, today is when you find that out. So the next time you take the test, you'll do fine on it because it's a really simple question. I know a couple of you that had that question, like, what do they want me to do? I said, oh, it's really simple. I'll tell you in a few weeks. So now I'm telling it to you. All right. Imagine if you had a sheet of paper. Hey, you got one in front of you. Don't do it to your sheet of paper. I used to do this in class, then I just found that people are just wasting paper. So I just have them do it as a mental exercise. I got a sheet of paper, yes?
Yeah.
I want you, I don't really want you to do it, just imagine. I want you to fold the piece of paper so that one side completely covers the other side.
Okay. Wait a minute.
Okay, so let's see. I got a piece of paper. I'm going to try to fold this side onto this side. So if I try to fold this side onto this side, do I completely cover up everything?
No.
Okay, so that line that I just made when I don't fold your paper.
Oh my
So
God,
this
Tom.
line that I just made on my paper is not what we're talking about because I was unable to completely cover up one side to the other side. Okay. However, there is a way to fold this. Obviously, you probably figured it out. If I go top directly to bottom, right, then I can in fact make it so that it completely covers itself up. Oh, that's not the only way to do this one because I also could have gone right over left or left over right. It would have completely covered it up. Okay. This is the concept that we're talking about, but check it out. We're not really talking about the shape. We're talking about the line that it just made. This line will have a name. And sometimes, as we saw on this one, the shape actually has multiple lines. Okay. All right, here we go. So that's what this is it in words, what we just did. These would be the two lines that if you folded it over, it would match perfectly. Rectangles are easy to wrap your head around. And those lines are called lines of symmetry. Box 1, write that down. Lines, that says lines. It could be lines, singular. But on the rectangle, we get 2 of them. Generally speaking, many shapes have more than one. It's a line drawn through a figure shape so that each side is a mirror image of the other side. In other words, it folds directly on top. Yes. We'll talk about that here in a second. And I will call on you. Lines of symmetry. Those are the imaginary lines. It doesn't say imaginary, but those are the imaginary lines that you can draw through. Let me see your piece of paper. Okay, give me everything here. Now write.
I need those.
Write. A line drawn through a figure so that each side is a mirror image of the other side. Easy concept. On that test you took, it said, how many lines of symmetry are there in this shape? So that's what they're asking you to do, is figure out how many lines can be drawn through the shape so that it folds directly over the other side. In other words, it makes a mirror image. All right, hey, what's the shape?
Triangle.
Triangle. If we fold this triangle, let's say the front is red and the back side is white. With me? If I fold the top to the bottom, does it cover itself up?
Yes.
Okay, well, let's fold the top over that line right there. So this, I said the front's red and the back is white. So if I folded that over, well, you get that. Does it cover itself up?
No.
No, because I can still see red. If it completely covers it, I won't see any red. So clearly, that's not a line of symmetry. Is there a line of symmetry?
Yes.
Where's the line of symmetry? Corner to corner? What do you mean?
Like that. Like a paper.
Yeah, but where would the line be? Like if you fold it and you open it up, where would the line be? Down the middle, right? So now if I fold this, remember white's on the back, then it would look like that, and well, yeah, you would get it. All right, lines of symmetry. Any object, any shape that's flat can have no lines of symmetry, can have one, or it can have many, right? It's one of these three. It's either going to have none, one, or many. Generally speaking, the many, they actually ask you how many lines of symmetry does it have. Okay. All right, so here we go. First shape. Anybody know what that shape is called?
Oval.
Oval. We don't call it an oval in math. We call it an ellipse. Okay. Actually, a circle is a form of an ellipse. All right, advanced stuff here. You have two lines of symmetry on this. Where are they? And these two, I'm giving you more advanced. This is not 8th grade math, but these are called your major and your minor axes. Agreed. Because planets go around the sun in, put the sun right here, and gravity will cause the planets to move in this shape, right? A circle is an ellipse where the major and the minor axes are equal, right? Notice this line is shorter than this one. If I make both of these the same, you get a circle. So a circle is an ellipse, right? We just don't say that. Okay, cool. 2. Pretty easy, right? I have no idea what that is, but how many lines of symmetry?
15 million.
Two.
If you fold it down the middle, then this side would fold over here and you get that. Well, that wouldn't work. Does this have any lines of
No.
symmetry?
No. Yes.
Which one? What? Could we fold it so that one side met the other side?
Yeah.
Where's the line of symmetry?
Everywhere.
Okay. So you can have a shape that has no lines of symmetry. It's possible. There's no way that you can fold it so it perfect. If you try to do top to bottom like that, well, you're gonna have overlap, right? Try to do left to right, that doesn't work. If you try to do diagonal, that doesn't work. There's just no way to fold this.
No, not diagonal, like down the middle.
Down the middle to the right.
Doesn't matter because this shape and this shape are not the same, right? Yes.
Wait, maybe if you like fold in the two.
Oh, we can't do that.
So you can't make more than one.
Yeah, you couldn't make a nice Yeah, I could fold that so I make a nice rectangle, and then it would, but I can't. I'm not allowed to do that. One fold, right? And one side has to cover the other side. Okay, so how about an arrow?
Yeah, you can. It's right down the middle.
Right.
No.
No, none. Right down the middle.
It's right down the middle.
Oh, none right down the middle.
One.
Down the middle.
Why are you saying none? They're all yelling straight down the middle, right? So if you folded it along this line, would it match? It would. I mean, if you like took scissors, cut, flipped it over, it would be exactly the same shape. Okay? You're confused on this?
It's okay, Kai.
Confused in the sense of you don't know what's going on.
Yes. How are we on
Okay.
5?
I'm going to give you a shape. I'm going to ask you to take a pair of scissors and cut it into 2 pieces so the 2 pieces are exactly the same. If I cut this along this dotted line, would I have 2 pieces the same or different? That's the idea of line of symmetry. Where you cut it is called the line of symmetry. Okay? Sometimes there's one line, sometimes there's multiple lines. How many lines of symmetry?
One.
Where? Right down the middle again. Okay? If we cut this and we took this and we folded over, would it be the same or different shape? If we went that way, it wouldn't work. So, what?
If I went that way.
If you went this way, you'd have one shape that looked like this and another shape that's bigger.
I know. It's a trapezoid. It looks like a trapezoids only have one line of symmetry. Look what you did. What did I do?
I should have had this ready because there's always one Doubting Thomas.
Wow.
Get your sheet out from the last night's homework.
Me?
Yeah.
Okay. I had it.
On your own, go to the page that has trapezoids. Cut out one of the trapezoids, and then we'll continue. All right, for the rest of us, we're moving on. How many lines of symmetry here?
One.
One, right down the middle. All right. Ooh.
Right down the middle
One.
again.
Two.
No, right down the middle. Yes, right down the middle.
If we did straight down the middle,
There's way more than one.
I think it's like
There's like 50 million.
that would work.
To the
Yeah.
diagonal.
Yeah.
1, 2, 3, 4.
What else?
5, 6. There's 6. There's 6.
Not
That's
that.
it.
Where do you want me to go?
Diagonal.
From where to where?
5.
The like. where
There's
I
four
put
more.
two
Do we
pieces
cut that?
Where to where?
I can move one at it.
Oh, I see. Yeah.
From
There, right there.
there down. from
Then
there.
draw it.
Oh, actually,
Okay, well, there's two.
3, 3, 3, 3, 3.
You were good until you did that.
Oh, wait, no, it's not.
Oh, what are you doing?
There's three.
4, 4, 4, 4, 4. There's 4.
Jackson, right there.
There.
Do it, draw it. Now, look,
No.
that would be this folded over here. That would be these two pieces would fold up here. Not there to there.
Oh, shoot. From there to
There to there.
Yeah, huh?
There's four, horribly drawn.
there.
So how many did we wind up with?
Five.
We wound up with 5.
That's how many.
By the way, it is not a coincidence that it has 5 points to it. All right, now take it and cut it in half and see, cut it directly in half and see if the left side equals the right side. All right, that one has 5. What is that?
5.
If you did not know, unlike what you've been told, all snowflakes have exactly the same shape.
What?
What's the shape?
They don't.
Star.
What's the shape?
Triangle.
Oh,
It's a-
octagon.
it's a-
Octagon.
It's a hexagon.
It's an X.
Do you see the hexagon?
Yes.
At the end of class, I will show you a picture. Now, what they say is that no two snowflakes didn't match, so you found the line of symmetry.
What kind of
Oh,
goodness?
wait.
Well, you didn't cut it
Wait,
down
Mr.
the middle.
Mr.
Now, let me
C.
talk, let me talk. Yes, all snowflakes look differently, but they are all hexagons. So, how many lines of symmetry?
4.
One.
Well, where would be one?
Four.
So, straight across, that would match up perfect. There's one.
Down.
All right, there's 2.
Both ends.
Is it diagonal?
3,
Yeah.
4, 5,
I don't know about that. Is it?
Yeah, it is.
All right, 3,
Other side.
4.
Other side.
Looks like there's 4.
5.
Oh, 5. So it is not a coincidence that a 5-sided star has 5 lines of symmetry and a hexagon has. Now that's because these are regular shapes. If they're irregular, they have no lines of symmetry. But if they're regular,
Okay.
so guess how many lines of symmetry an octagon has?
8.
If it's regular.
So.
Remember, all the sides are the same, and all the angles are the same.
So in Star Wars, they have the same shape as in the middle, but so then that would make them little pretty snowflakes.
Okay. All right. Genevieve,
Infinite.
why infinite?
Circle.
As long as the line goes through the center. So in other words, you're making diameters, right? So if you make a diameter, no matter how you make the diameter, that would be a line of symmetry. Who's lost? What part are you lost on? All right.
That's you, Ty.
How many lines of symmetry? Hey, stop. How many lines of symmetry? Anybody want to make an argument that it
Yeah,
has?
yeah,
What?
right down the middle because if you fold it.
That's what he said.
Oh, that's right.
No, one knows more bigger than the other.
It's true.
There's 8. There's 8. One from the top right to the top left.
How would that, his head would be down here. It wouldn't cover up the chin.
Okay, so.
All right, time out. What were you gonna say, Brecton? Why none? So it turns out that the human face, you could make an argument if it's drawn on a computer, has how many lines of symmetry?
Infinite.
One.
One, but in reality, a real human face has 0. Now, like I said, if you drew this on a computer, you certainly wouldn't make one ear bigger or weirder than the other one. Your ears would be perfect. So when you draw things on a computer, you can make it symmetrical, right? However, in real life, I mean, even the eyes, one eye is higher than the other one, right? Eyebrows are not the same. They're not symmetrical.
Oh, yeah.
Okay.
Let's hold them,
Human
baby.
faces are close to being symmetrical, but they're not. All right, so we would say none. Okay, and that's the other thing.
Oh, let's.
All right, so
Oh, yeah.
that is listen, please. Listen. Waiting on you. Okay, that's the easy part of the class. Finding lines of symmetry. Not very challenging. When you take the test the next time, when you get to that question, how many lines of symmetry, now you know what to do. The other thing that they ask you to do on that test, it's not because I'm teaching you the test here, it's just that's what 9-4 is about. The other thing on the test that some of you had problems were these things called reflections. And you're like, well, what do they want me to do? There is also rotations and dilations, they come later. But we will talk about today something called reflections. All right, write this down, box 2. Rotations, reflections, dilations, and translations are all forms of something we call a transformation. I should see pencils moving, Jaden. I should see your pencil moving. Box 2, a transformation. That's when you take a shape and you either change its size, make it bigger or smaller. That's called a dilation. You change its orientation. That's a rotation. You change its position. That's either what's called a translation or a reflection. Those are all called transformations. Today, we will just be concentrating on positional changes. There's 2 ways of doing it. One called translation. We'll do that later, not today. But we will do a reflection today. A reflection uses the concept of a line of symmetry in some sense. All right, so today we're going to be doing something called a reflection. This is a transformation that flips a figure over a line. It's not going to be called the line of symmetry. It will be called a line of reflection. Jaden, put the book away, grab your pencil, and write what I'm asking you to write. Reflections are I think they're the easiest transformation. Some would say a translation is the easiest. Oh, it's pretty easy, but so is a reflection. Tonight for homework, the majority of your homework will be on making reflections. When you get to Algebra 1, you don't see reflections. When we get to geometry, you see reflections. When we get to Algebra 2, pre-calculus, calculus, you see reflections.
Oh, is this stuff where we had to figure out if it could mirror?
Yes.
That's easy.
It's not that if it mirrors, they want you to make the reflection. You will be doing the reflections today. All right, here we go. All right, piece of paper, right? Here's the basic idea of a reflection. You will be told where is the line of reflection. It may be in the middle, it may be vertical, it may be diagonal. You will be told, here is the line of reflection. You will be given a shape of some sort or a point. We'll start off with points, make it easy. Okay, The line that you reflected over is called the line of reflection. Then you will have a shape. Well, the points aren't shapes, but imagine this was a circle. Okay. I want to reflect this thing over that. Well, one way of thinking about it is what we're doing is we're taking that dot and we're flipping it, it would wind up right there. Well, that's hard to do. You don't want to be folding your paper 46 different times. So there must be a math method. Here's the math method. You measure the distance between the original shape and the line of reflection. So let's say this is 3 inches. Then guess what you do? You go on the other side in a straight line and you rewrite that, in this case, this point. We got a problem. If we move it, is it now point A? And for those of you that took the test, you're like, what does that mean? This is what this thing means. When you do any transformation, the first time you move it, you put a symbol that indicates you just did a transformation. And that symbol will be a little tick mark. So you saw that, and we call this tick mark prime, P-R-I-M-E notation. So when we move it, whatever that distance is, we can't call it A, we call it A prime. 1 tick mark means how many times have you transformed it?
1.
There's 2, you've done 2 transformations, 3 transformations. I know on the test they had one where there was 2 of those. And meant there was a reflection and a rotation or something. That's the idea, and that's what we're going to be doing. You're like, well, that doesn't seem that hard. It's not. It's literally that easy. So let me show you how this is done. All right. So they will give you a shape. We'll start off really easy, a point. Now, you got to be able to graph the point correctly. A is at 2, 3. So let's see. 2, 3 is right there. I graph my point. Now I read it, and this is where you'll mess it up because you don't read it carefully. It says, reflect it, Jenna, over the... Where is that? Show me with your arm. Show me with your arm the x-axis. Which way does it go? It doesn't go that direction. It doesn't go that direction. It goes both directions. The x-axis is the whole darn line. By the way, if you forget which one is the x and the y, they're labeled. So the x-axis is now your line of reflection. You take your magic marker, pencil, whatever, and you count. How many squares is A from the line of reflection? It is 1, 2, 3 from the line. You don't count the one you start on, but you count down to the line of reflection. 1, 2, 3. Therefore, where is it going to wind up? It's going to stay on this line, but it's going to be on 3 below that line. Okay, if you can do the math, that's fine. But at this point, we don't need to do the math, but we do need to count squares. So we count 1, 2, 3. And now we call that
A prime.
we call that A prime. Who's lost? Okay. We start with the point. We got to graph it in the right spot. We see what it's asking us to reflect over. It's either going to be X or Y axis. We draw that. We count how many squares it is from that point to the line, and we apply that below the line, or to the left of the line, or to the right of the line. Abby, what's up?
So, what would it be called if you like took that spot where it is right now and put it into like quadrant 2? Like,
That would be a reflection over that line. See what I mean? Next year we will do that, not this year. This year, all we're going to reflect over is X and Y. Okay. But yes, if you wanted to get put in quadrant 2, then you would reflect it over the line. In this case, Y equals X. All right. A bit too complicated for this year. By the way, the answer is where it winds up. It's at 2, -3. Done. All right. One more time. B, -4, -7, down here. I need to reflect it this time over the Jenna. Why aren't you paying attention? Why is not your eyeballs on the board?
Why is not your eyeballs?
That's why I'm a math teacher, not the language arts teacher. Why are your eyeballs not on the board? Yeah, but I'm saying I want you to pass. You're not going to pass by looking at your lap or your book or your whatever it is that you're distracted by. Look at the board. Thank you. Hey, here's B. We're reflecting over the y-axis. Find the y. Do you have to make it dark? Do you have to make it dark like I'm going to do right here? Don't have to. If it helps you, do that. Hey, how far is B away from the red line? Well, we count squares. 1, 2, 3, 4. It stays on the same line and winds up
Or
4 on the other side. Call it B prime and you're done.
this is great.
Easy or hard?
Easy.
You have to stay on the line. Angie, wake up. Okay. Who's already done box 3 while I was talking? All right, the rest of you do it. And then we'll get to the more challenging ones. And they do get more challenging.
It's too scary. Can I get my stuff?
No.
Looks like a tear.
First one is B. It's at 5, -4. I graph 5, -4. I read what it says. I'm going to reflect over the x-axis. You can screw this up if you're reflecting over the wrong axis. I find x is right here. It's horizontal. I count how many it is to the x-axis. It's 1, 2, 3, 4, and I apply that to the other side. 1, 2, 3, 4. Put a new dot, call it B prime, done. Second one, -6, 3. There's point A, -6, 3. It says this time reflected over the y-axis. Once again, if you're going to screw it up, you pick the wrong axes. Hey, here's y, it goes up and down. So I'm counting to that line of reflection. I'm right here, so I'm going to count 1, 2, 3, 4, 5, 6. Therefore, it winds 6 on the other side. 1, 2, 3, 4, 5, 6. Hey, it's right next to B prime. There you go. Who's lost?
Oh, that was pretty
Can you do
easy.
points?
Yes.
Let's do shapes.
Oh, no.
Oh,
All right, here we go. What's the shape?
square.
That's a rectangle.
No, it isn't, because there's 5 on the side.
1, 2, 3, 4, 5. 1, 2, 3. Why does that not look like a square?
Give me a
1,
give me a
2,
point.
3,
Give me a
4,
point.
5. I think I stretched it.
Oh,
All right, here we go.
John, get a point.
Well, does it look like a square?
No, it looks like a
All right.
rectangle.
We're both
Looks
right.
like thing.
All right, up here. So how in the world do you do this to a shape? Here's how it's done. The easiest way to do it, you're not going to do it to all, I mean, there's an infinite amount of points that make up the shape. You're going to only do it to the vertices of the shape. So you're going to pick each corner and apply that transformation, the reflection in this case, to that. So one corner at a time, it doesn't matter which one you start with. I'm going to start with, and I'm doing it over the x-axis. It says over the x-axis. So I pick a corner, that one right there. I do that same process. I count 1, 2, 3, 4, 5, 6, 7, 8, 9. So I move it 9 down. That's my new point. How many corners does it have?
Oh.
So I need another corner.
Oh, no.
I count 1, 2, 3, 4. So I go.
1, 2, 3, 4.
Notice it went red, yellow. Now it goes.
Yellow, red.
Because think about it, if you flipped it over, the top would be the bottom and the bottom would now be the top. That's why the colors don't match now. How many more times do we need to do this?
Yellow.
Well, twice.
Twice more. Or you could
One
use
more.
some thought process. If it goes 5 across, you now have enough that you can go 5 across and down. But if you want to do it to all 4 corners, you can. You get the shape. Who's lost on what I just did? Easy or hard?
Easy.
Pretty easy. It will get complicated on the back. All right, let's do one. Box 4. Here we go. We got a triangle. How many corners do we need to move?
3.
We need to move 3 corners one at a time. We are going over the y-axis this time. I'm going to do the top one first. So it goes 1, 2, 3, 4, 5, 6, 7. So I got to count 7 over. 1, 2, 3, 4, 5, 6, 7. Put a dot. I'll do this corner. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Put a big honking dot. Last one. Looks like we're moving 10. So I move it over 10. Play, connect the dots. There's my triangle. For which one? 1, 2, 3, 4, 5, 6, 7, 8, 9. Count again.
What did you say?
8.
Which one?
You top?
It could be, I may have made a mistake on the thing. I'm not doing the top, I'm doing the lower left.
I don't know, but 8. Oh. 2, 8, not 9.
All right, now he's got 9. Who's lost? And you're like, how can I make this hard? It becomes hard when the shape is, somebody take a guess,
Inside the square.
on one of the axes. Flip the paper over. This is where it gets ugly. All right. First one isn't ugly. It's pretty easy, but the next two are ugly. Once again, hey, if I'm reflecting over the x-axis, look at it. Here's the x-axis. I got to move E to the other side. This is where it gets ugly. You ready? E is how far away from the x-axis?
0.
E is 2.
Oh.
Therefore, it has to go 2 down, 1, 2. It winds up right here. Here's E prime. It's 2 from the x-axis, so it will be 2 below.
Wait, are we just flipping?
We are. We're taking this whole thing and we're flipping it
Oh, I thought you meant like we're gonna like
over. That would be over the y-axis. We're doing it over the x-axis. Okay, here's a problem. D is 1 below, so it's going to be 1 above, and it stays on that line. It gets messy. G is 1 above. It's going to be, there's G prime. F is 1, 2, 3, 4 above. It's going to be 1, 2, 3, 4. And that's F prime. Now, when you play connect the dots, you get this big honking mess. Look at this. It overlaps the other one. It's okay. What?
Oh, yeah.
I have 1 above the.
What?
Why did I 1 above
It's a tick mark. That means that it's been transformed one time. It's not a 1. It's actually a apostrophe.
Silly thing.
You see 2 apostrophes. It's had 2 transformations. All right, you got that one?
Yep.
Now get uglier.
No.
This one is going across the Y.
So you will flip it.
I'm going to take the whole thing. I'm going to flip it like this.
Oh,
How far is L away from the y-axis?
0.
-1.
How far is L away from the y-axis?
0. 0.
It's on the y-axis, so if you flip it, does it move?
Oh.
No, it stays there. We will not call it L prime. But K is how far?
2.
Count 2.
1. 1.
So therefore, it will be
1.
1 away, K prime.
I love this concept.
How far is N away?
Oh,
So it'll be 1 away.
uh,
M is a little bit harder to see. It's
3.
1, 2, 3. So it's 1, 2, 3. There's your M. When you play connect the dot, you get this big honking mess.
you gave us all of these, right?
What? I don't know. It's an expression. Don't ask me. I heard it somewhere and I'm just repeating it. There. Good Lord, that's ugly.
That is really
Let me
ugly.
fix your mistake. So this is.
There's no mistake. That's what it turns into. You can kind of see, okay, this one went up and down. This one goes up and down. This one has an angle. When you flip it over, well, it's the same angle. You see a nice little triangle right here?
There's lines of symmetry. Wait.
There are no lines of symmetry on that shape.
No, on this shape. On this. No.
The next one has lines of symmetry.
No. That's like a trapezoid.
Stop it.
That angle is not that.
Oh, I'm sorry. I was looking at his. Yeah, you're right. There are none on that
Yeah.
one. All right, last one. Last big mess, and then the bell's going to ring. Let's go. Hey, over what? Over the X. So that's this one. G is on the X-axis, so it doesn't move. G prime. H is 2 above, so it goes 2 below. H prime. I is 2 below, so it goes I prime. And F is what, 3? 4. 1, 2, 3, 4. 1, 2, 3, 4. Play connect the dots. Boom, 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 boom. And you're
Oh, worksheet. Worksheet.
worksheet.
I like
it.
Yeah, this is kind of fun.
The one that said
You can make cool shapes. No.
I would know.
Got A and J. Wait, what? I heard it. I would know.
No, you would. I don't know.
Jackson's like, I would know, like. No. G-R-O-S-S.
Dude, who you dead?
Any doodle the right in front of the teacher too.
I'll just go stuff.
Where's Priscilla? I gotta go. Priscilla's in the backside.
Sorry, Daddy.
Because. Oh.
Christian, you're letting everybody step over you. Front bed. Front bed. Or you're being very nice. Are you trouble, Jade? Front bed. In front bed. Whatever the rule.
What?
Oh. You hit your guys' goal. So I would have. I need to have tutoring today. I'm not just a computer.
Well, luckily you're not in contact. Take your head off too.
Was there anything
Yep.
No.
Flip the board, copy down.
Did you pick up like a missing seventh grade math book or something?
3 days ago,
I've been fine.
it's on the top of the cabinet. One more time?
I said I have a 504. Use it on YouTube.
Your mom already emailed me and I said yes. She said you were sleeping. How am I going to tell if you're sleeping if your eyes are open?
I wasn't sleeping. I was like,
Okay.
so like
She said you were sleeping and I
was
said,
writing
I
stuff
said,
down, but it was pretty
I
much.
asked her multiple questions and she answered them correctly. And I was like, well, so how do I know if she's sleeping?
I don't know. Like I
Talk to your mom and tell her you weren't sleeping.
I didn't understand the homework at all.
Yes, you can come into the room. But you gotta have the formulas written down.
I do have the formulas written down. I was just super confused.
Go wash your hand first.
Is it camo bandit? I don't talk to Miss Coleman. Miss Coleman has camo bandits. They want to know these stuff. Sure.